Hello, welcome back to Statistics and Mathematics YouTube channel. Please kindly subscribe to my channel. Today we are going to continue our discussion on questions and answers on negative binomial distribution. So let's dive into the questions. Question 1 says, x is a negative binomial random variable with p is equal to 0.2 and our k is equal to 4. Calculate the mean. Probability that our x is equal to 20, probability our x is equal to 19, and probability our x is equal to 21. Okay, so there is the PMF for negative binomial distribution, where our p was given in the question to be 0.2 and our k was given because our p was given. So k will be 1 minus 1, p which is 0.2, and then we get 0.8, and our k was given in the question to be 4. So the first question said expectation of x. Expectation of x2 is equal to k divided by p, of which you are going to get 4 divided by 0.2, which is equal to what? 20 to be our expectation. Okay, and then for our PMF, we are saying that our PMF here will be x minus 1, k minus 1, okay? K minus 1, p raised to the power k, 1 minus p raised to the power x minus k. And then we know that for this our x, okay, for this our x, pertaining to this question, our x was given as 20, so we are going to get 20 minus 1. And then our k was given in the question to be 4, which will give us 4 minus 1, okay? And then our p was given as 0.2, which will be raised to the power of k, which is 4, and then 0.8, which will raise to the power of k, x minus k, which is going to be what? 16. Once we punch this on the calculator, we are going to get our final answer to be what? 0.04363. Okay, and for probably our x equal to 19 too, we are going to do the same thing, right? Once you subtract 1 from 19, you are going to get 18. Subtract 1 from 4, we are going to get 3, and then this is what you are going to get. Point it on the calculator and you get our answer to be 0.0459. And then probably that our x is equal to 21 to the same thing, and we are going to get our final answer to what? 0.04107. Okay, question 2 says an auditor review a manuscript until she has read 3 acceptable ones. The probability that a manuscript is acceptable is 0.15. Find the probability that our x is equal to 20. So I'm going to find probability that our x is equal to 20. Okay, so right now what we have to do is to just get our k. Our k from the question was what? 3, and then our p was given to us as what? 0.15. Okay, and our k was given to us 1 minus what? P, which is 1 minus 0.15, and then we are getting that one to do as 0.85. So once we have this and our x2 is being given to us to do at 20, we just substitute this one into the PMF, x minus 1, k minus 1, p raised to the power k, 1 minus p raised to the power x minus what? K. And then we are getting this one, right? And our final answer will be at 0.03643. Okay, that is that. And then this what? This is our question 3. Okay, it says the moment generating function that identify the distribution. Before we can calculate the probability for the b, we have to know which distribution this moment generating function follows. Okay, let's simplify this one to know the distribution. Okay, so here we are going to get e raised to the power t, 4 minus 3 e raised to the power t, all raised to the power 7, and this one can be simplified as e raised to the power t. We have to simplify the 4 out 1 minus 3 divided by 4 e raised to the power t, so that when you multiply through by 4, we are going to get this denominator. Okay, and then this one will be equal to e raised to the power t all divided by e raised to the power t all divided by that. But you will see that when I have a fraction at the top here, 1 over 4, right, it's the same thing when I omit it, right? 1 over 4 here, let's assume this is not there, right? Is it not the same thing as me writing e raised to the power t divided by 4 is the same thing, right? So here will be 1 over 4, 1 minus 3 divided by 4 e raised to the power t, all raised to the power what? 7. Okay, and then this resembles what? The moment generating function for the negative binomial, that is p e raised to the power t, bracket open, 1 minus q e raised to the power t, all raised to the power what? 7. Sorry, that is k. So here we can deduce our p, which is given as what? 1 over 4, q to be what? 3 over 4, and then our k to be what? 7. So once we have it, we can work on what? The b. Probably that our x is less than 8, less than or equal to 8. Okay, probably our x is less than or equal to 8, right? Let me clean this one so that we work it here. Probably our x is less than or equal to 8, right? Will be equal to, probably our x is less than or equal to 8. Okay, will be equal to summation, where our x is moving from 0 to what? Infinity of x minus 1 of sorry, we are going to start from 1, okay, right? So of 7, okay, because you are going to sorry, 6, 7 minus 1, okay, that is k minus 1 times p raised to the power k, which is 6. 1 minus p raised to the power, that is x minus what? K, which is 7. Okay, so this is what you are going to get. And you can see that when x is equal to 0, when x is equal to 1, it will not work. When x is equal to 0, it will not work. When x is equal to 3, it will not work. The only instant that it can work is probably that our x is equal to 7 plus probably our x is equal to what? 8. That is the only instant these two will work. Okay, so you are going to solve for probably our x equal to 7 plus probably that our x is equal to what? 8. Okay, that is what is being done here. So once we add the two, right? Once we add the two, we are going to get 0.00388147. That is what we are going to get. And then we have been asked to calculate probably that our x is greater than or equal to 8, which is equal to 1 minus probably that our x is equal to what? 7. Okay, we are going to get 0.999386. okay, that is the solution. And then question 4 says x and y are independent negative binomial random variables with the parameter kp and then rp. And we have been asked to find the moment generating function for x plus y. This one is very simple. Okay, so you have to generate moment for k and then p for the parameter, first parameter, right? And then for that one, we are going to get p e raised to the power t all divided by 1 minus k e raised to the power t all raised to the power k, because this is our k. Okay, and then we are going to do same for this one, of which we are going to get this moment generating function. So since they are independent negative binomial distribution, you are going to multiply the two. And once you multiply the two moment generating function, let's assume the comma is not here and we are multiplying the two. We are multiplying this one and that. Since they are having the same base, we are going to add the exponent. That's the reason we are getting k plus r here. Okay, and the second one says we should describe the distribution. And if for us to describe the distribution, this two depict what? Negative binomial distribution. Okay, so we are saying that the sum of the independent negative binomial random variable with the same p is what? Also a negative binomial. Okay, so thank you for watching and then reading on my channel. Please don't forget to subscribe, like and share so that this video will get to your friends for them to also benefit. Bye. Have a lovely day.